In a diesel engine, the compression ratio is 13:1. That means RC, the compression ratio is equal to 13:1. That is equal to 13. And the fuel is cut off at 8% of the stroke. Say clearance volume is equal to VC. So in this diagram we can see this is for process 1, 2 and 3. The volumes are V1, V2 and V3, and this is clearance volume VC, and this is stroke volume. So we assume that VC is the clearance volume, and which is equal to V2 from the diagram. The fuel is cut off at 8% of the stroke. When the piston moves from TDC to the BDC, then this is cut off at 8% of the stroke. So we can say V3 minus V2 is equal to 8% of Vs. What is that? V3 minus V2, that is equal to 8% of Vs. So what is V3? V3 is equal to 8% of Vs plus V2. Now if we divide by V2 on both the sides, V2, then it will be equal to 0.08 into Vs by V2, which is actually equal to Vc, plus Vc divided by Vc, that will be 1. So what is V3 divided by V2? That is equal to low cutoff ratio. So it is 0.08 Vs divided by Vc plus 1. Rc is equal to V1 by V2, and this is also is equal to Vc plus Vs divided by Vc. So Rc is given as 13, and that is equal to 1 plus Vs by Vc. Vs divided by Vc is equal to 13 minus 1, that is equal to 12. So we'll use this value. So if we put that value 0.08 into 12 Vs by Vc plus 1, and that will be equal to 1.96. So cutoff ratio is 1.96. Air standard efficiency of diesel cycle, which is equal to 1 minus 1 by Rc to the power gamma minus 1 into 1 by gamma into rho to the power gamma minus 1 divided by rho minus 1. So we just have to put the values. 1 minus 1 by Rc is equal to 13. 13 to the power gamma. Gamma is given equal to 1.4. So this is equal to 0.4 gamma minus 1 into 1 by gamma, that is 1.4, and that is equal to, so 1.96 to the power 1.4 minus 1 divided by 1.96 minus 1. So if we do the calculation, then you can get the value of eta d, and if my calculation is correct, then it will be equal to 0.5825, which is equal to 58.25%. In this problem, the diesel engine has a swap volume of I changed this value to 9 liters. It is 9 liters. Swap volume is 9 liters. That means Vs is equal to 9 liters, and that is equal to 9,000 cubic centimeter or cc. And the clearance volume, Vc is clearance volume. We can refer this diagram. Okay, this is 1, 2, Vc, Vs, and this is equal to V3. This is V1, this is V2, V2 equal to Vs, and this is the 0.3, this is 4. Now in the problem, the clearance volume is 8% of the stroke. So Vc is equal to 8% of stroke, that means stroke volume, and that is equal to 0.08 multiplied by Vs, that is 9000 cc, and that is equal to 720 cc. In this problem, it is given that initial pressure and temperature is 1 bar and 27 degrees centigrade. So T1 equal to 1 bar, T1 equal to 27 degrees centigrade, and that is equal to 300 Kelvin. And the compression ratio is 5. So RC is equal to, not 5, compression ratio is 15. And the cutoff takes place at 7% of the stroke. Right, V3 minus V2, this is the cutoff, is equal to 7% of the stroke, that means Vs. So V3 is equal to 0.07 into Vs plus V2. So Vs we know, that is equal to, and Vc is equal to V2. From PV diagram you can see V2 equal to Vc. So 0.7% of Vs, 0.07 multiplied by Vs is 9000 plus V2 is 720, and this is equal to 1350 cc. So now cutoff ratio, we have to find out cutoff ratio equal to V3 divided by V2, that is equal to 1350 divided by V2 is 720, and that is equal to, I think it is 1.875. So we got the cutoff ratio. Now we need the gamma, so we assume that gamma is equal to 1.4. So with this value we can calculate the air standard efficiency. So in this diagram you can see this is the stroke volume Vs, and this is the clearance volume. This part is clearance volume. So efficiency, now we have to find out the heat supplied per cycle, and the heat supplied is during the process 2-3. So if we say QS heat supplied, that means heat added during the process 2-3, and this is a constant pressure process. So heat supplied is equal to M Cp temperature difference, that is equal to T3 minus T2. So in this case mass is not given, so we'll find out for 1 kg of mass, that means per kg mass. And the Cp is specific heat capacity of air at constant pressure. So in this case we have to assume the value of Cp, say 1.007 kilojoule per kg per Kelvin. So we need value of Cp, which we can assume. We need temperature T3, which we do not know, and also temperature T3. So first, to find the heat supplied, we have to find out temperature T2 as well as temperature T3. Now to find the temperature T2, we will consider the process 1-2, which is equal to, is a isentropic compression process. So for process we can apply the isentropic law, and according to that law T2 divided by T1 is equal to V1 divided by V2 all to the power gamma minus 1. That is the isentropic law, the relation between temperature and volume. And V1 by V2, what is V1 by V2? That is equal to RC. RC is equal to V1 divided by V2. So we can write RC to the power gamma minus 1, and that is equal to RC is 15 to the power 1.4 minus 1, and this is equal to 2.954. So from this we will get the value of temperature T2, which is equal to 2.954 into T1, and T1 is 300 degree Kelvin, that means 27 degree centigrade. So from this we will get 2.954 into 300, and that is equal to 886.25 in Kelvin. We have to find out the temperature T3 now. Now to find the temperature T3, we have to consider the process 2-3, and process 2-3 is constant pressure process. So for process 2-3, we will apply this law. P2 V2 by T2 is equal to P3 V3 divided by T3. P2 equal to P3, constant pressure process. So it will be like this. T3 is equal to V3 divided by V2 into T2. So V3 divided by V2, we already know V3 is equal to 1350 divided by 720 V2 into temperature 886.25. This is I think it is 1661.7 Kelvin. The heat supplied Qs is equal to M is 1 for 1 kg of mass. Cp will put 1.007 kilojoule per kg per Kelvin, and multiplied by T3 minus T2, 780.87 kilojoule, if my calculation is correct. Now another problem. The cylinder diameter of a diesel engine is 16 centimeter and stroke is 21 centimeter. The clearance volume is 10% of the swept volume. Determine the compression ratio and the air standard efficiency of the engine, and it is given that the cutoff takes place at 7% of the. In this case, the cylinder dimensions are given. You can look at the PV diagram for process 1-2, in which the piston moves from this BDC to TDC. That means this is the stroke length L, and which is given as 21 centimeter, and the diameter of the engine is 6 centimeter. So engine means the cylinder diameter. So suppose this is the cylinder. So diameter of this cylinder, that means this diameter is 16 centimeter. 16 centimeter diameter. Okay. Now the piston moves from TDC to BCT like this. This is the movement of the piston from TDC to BCT, and this volume is the clearance volume VC. Now first we have to find out the VS. So for that, diameter of the cylinder is given 16 centimeter and the length of the stroke is 21 centimeter. So this diameter is given. So this area, cross-sectional area A, we have to find out. So cross-sectional area A is equal to 5/4 into D square, that means 16 square. So it will be is equal to 804.3 centimeter square. Now Vs, stroke volume, is equal to area into length of the stroke. So this is equal to 804.3 into length of the stroke is 21. So this is cc, cubic centimeter, and that is equal to 16889.2 cc, cubic centimeter. So Vs we find out. Now what is Vc? Clearance volume is 10% of the swept volume. In the problem it is given. So this is 10% of Vs. So it will be equal to 168.92 cc, 10% of the Vs. We have to find out Rc. So compression ratio Rc is equal to V1 by V2. From PV diagram you can see that is the compression ratio, and that is equal to Vc plus Vs divided by Vc, because V2 equal to Vc. So if we put the value 168.92 plus Vs, which is equal to 16889.2 divided by 168.92, then it will be equal to 11 approximately. So this is the compression ratio. The first part is completed, which is determine the compression ratio and the air standard efficiency we have to find out. But to find out air standard efficiency, we have to find out the cutoff ratio. And for that it is given that the cutoff takes place at 7% of the stroke. So what is the cutoff? I am not talking about cutoff ratio, but cutoff is V3 minus V2. That is equal to 7% of Vs stroke. So that is equal to 7% of Vs. So 0.07 multiplied by Vs is 16889.2. That will be equal to 1182.24. So from this we can find out V3. V3 is equal to V2 plus 1182.24, and V2 is Vc. Okay, V2 is Vc. So this is equal to 2871. Now we'll find out cutoff ratio. Rho is equal to V3 divided by V2. So that is equal to V3 is 2871.16 divided by V2 equal to 168.92, and that is equal to 1.7 approximately. So this is the diesel cycle. So air standard efficiency of the diesel cycle is 1 minus 1 by Rc to the power gamma minus 1 into 1 by gamma into rho to the power gamma minus 1 divided by rho minus 1. We can put the values. 1 minus 1 by 0.56. So efficiency of the diesel cycle is 56.91%.